All right, so in this problem, we are given two triangles. Triangle number 1, which is the larger triangle, and then triangle number 2, which is the smaller triangle. The question is asked, what rule was used to dilate, to transform triangle 1 into triangle 2? Now, there's a couple of things that we want to keep in mind. Anytime we're dealing with dilation or an increase or decrease in the size, we're dealing with scale factor. And if we're dealing with scale factor, we know we're going to multiply. All right, anytime we have an increase in size or a decrease in size, we know we're going to multiply. If it's an increase in size, we know we're going to multiply by a number greater than 1 because the scale factor is bigger than 1. If we're decreasing in size, we know that we are going to be multiplying by a number less than 1. All right, so in this case, from triangle 1 to triangle 2, we are decreasing in size. All right, so what you want to do in this situation is you want to find one point to see, or a set of points, I should say, to see if you can figure out what the rule is. And then once you think you have the rule, then you want to test what you think it is on a different set of points to see if that rule holds true. Now, I'm not going to start with these points up here because I have zeros involved. And since I'm multiplying, that's going to make it very challenging because if I'm dealing with zeros, anything times 0 is 0. So I want to have a rule for x and a rule for y. So I'm actually going to use this set of points here, which is 2, -3, and 4, -6. So the question is, how do I get from this to this? Or excuse me, let's go the other way. How do I get from this? Because remember, we're going from triangle 1 to triangle 2. How do I get from 4, 6, which is this corner down here on triangle 1, to 2, or excuse me, 4, -6, to 2, -3? How do I get from this point to this point? Well, the answer should be relatively obvious. Each of these is being halved, basically. So 4 becomes 2, we're multiplying by 1/2, or we're dividing by 2. -6 becomes -3, again, we're multiplying by 1/2, or dividing by 2. So my rule would have 1/2 x and then 1/2 y. That would be the rule that you would see here. So now what I want to do is, since I think I have the correct rule, now I want to look at another set of points and see, does this rule hold true? Well, if you look over at these other two, this is just a mirror. The only difference is that now my x value in those points is a negative. So I know that's going to hold true here. So let's take a look here. From 0 to 0, anything I multiply by 0 will be 0. So we know that that is true. To get from 6 to 3, well, that's pretty simple. Because yeah, 6 times 1/2 would give me 3. So this rule holds true. So again, the thing to keep in mind, because the triangle is shrinking, because it's getting smaller, then I know I'm going to be multiplying by a number less than 1. If this was flipped, if this was inverted and we were going from 2 to 1, then we would have an increase, and I know I would need to multiply by a number greater than 1. All right, so in this problem, we are dilating circle 1 into circle 2. Now, as we talked about in the previous problem, because we are increasing the size of the circle, we know we're going to be multiplying by a number greater than 1. And so our task is then to figure out, well, what is that number going to be? Now, this is a little bit more challenging because we're going to have to deal with multiple sets of points to get our rule. We can't rely on just one set. So, for example, if I go from 3, 0 to 8, 0, I'm not going to be able to find the rule for my y value because both of my y's are 0. So I'm going to have to do a little bit more on this one. So the first thing is, how are we going to get from 8 to 3? What are we going to multiply 3 by to get to 8? Well, the simplest thing to do here is just to say 3 times 8/3. I mean, that's really the easiest thing to do. This is not a good, clean conversion, and 8/3 is not going to simplify. And so this is the most accurate way for us to write it. And if we look at our answer choice, we've got several answer choices in fraction form, so we're good to just leave it that way. All right, so my rule for x is just going to be 8/3 x. All right, now I've got to do this. Now I've got to do the same thing for y. Now they were pretty kind to us here because our y transformation is the same as our x transformation. So we're, instead of going from 3,0 to 8,0, we're going from 0,3 to 8,3. And so it's going to be the same thing. We're multiplying by 8/3. And so our rule will be 8/3 x, 8/3 y in our dilation. So problem number 3 looks very similar to problem number 2. We are dilating a circle from circle 1 to circle 2, so we are increasing its size. So what I'd like you to do is, if you haven't already, I want you to pause the video and attempt to do this problem on your own, and then use the work I'm about to do to check and make sure that you've done it correctly. Okay, so hopefully you are staring at a completed problem and you're just anxiously waiting for me to verify that your work is correct. So I'm going to go ahead and write the rule up here, and then we'll talk about why. So again, because we've got a circle, the points that are easiest to identify are the ones that are on the axis. So for my x rule, I know I'm increasing by 7/4 because I'm going from 7 to 4. So in order to get from 4 to 7, I'm just, in a multiplication problem, I'm going to multiply 4 by 7/4 to get 7. So that's going to be my x rule. And then my y rule is going to be the same thing, all right? Because we're going from y value of 4 to y value of 7, and so we're going to multiply by 7/4 there as well. Again, biggest thing to remember, because the circle is increasing in size, I know I'm going to multiply by a number greater than 1. And then it's just a matter of finding out what number can I multiply by my x value and my y value to get from circle 1 to circle 2. So in this problem, a little bit different because we're not on a coordinate plane, but we are dilating from this rectangle, this ABCD rectangle, to this ABCD prime rectangle. And we're not actually given the value of the scale factor, which makes this even a little bit more challenging. But we're asked to come up with a formula to find the area of the rectangle, of this new rectangle. Now, we got to understand a few things here. The first thing is we're not going to end up with an actual numeric value because our scale factor is x, because we're going from 9 to 9x here on this, this AB segment and A prime B prime segment. Because our scale factor is x, we're not going to actually end up with a value here. We're going to end up with an expression, basically, or with an equation. Actually, they have it written in an equation form. So we have to think about what would our values be in this area formula. So our area formula, we know, is length times width. All right, we're going to go ahead and use this segment here as our length. All right, and I'm going to go ahead and replace the a with a y because they have the area represented as the value of y. So we're going to say y equals, and then we've got 9x, and now we have to multiply by whatever this value is. All right, so the thing we want to think about here is our scale factor from this AB segment to this A prime B prime segment is x. Now we don't know what that value is, but we know that it is represented by this variable x. So when I'm thinking about what is the scale factor for AC to A prime, AC prime, these two segments, I've got 4, and I know the scale factor is going to be consistent, so it's going to be 4x. So this is my value now for my width. So we end up with 9x times 4x. Now, this is where you can get yourself into trouble if you're not careful, because there are 2 answer choices now that are very tempting. Answer choice F and answer choice G. And the only difference between the two is that one of them has x squared and one of them does not. So this is what we need to think about. This problem is basically saying 9 times x times 4 times x. All right? So, as we're thinking about that, 9 times 4, that's going to give us 36. And then we've got x times x. Well, what is x times x? Well, that's x squared. All right, so be careful in this as you're doing this to make sure you're really thinking through what 9x times 4x would actually be. So this final question on this particular practice set really gets to, do you understand the concept of scale factoring and what's going on? So we're given this rectangle, this PQRS rectangle, and we're asked to come up with a rule without another rectangle, and really without a specified scale factor. We're just told that our scale factor is going to be k. All right, so we've got to come up with a coordinate, a set of coordinates for this r prime value with just this information, and that's all we're given. But again, if we can think about, does it matter what value k is? If k is bigger than 1, less than 1, doesn't matter. Because it's scale factor, we know we're going to multiply it by each of these values. All right, so really, it's just a simple matter of saying 3 times k, because right now, r is at 3 for its x value, and then negative 3 times k for the y value, because r is at negative 3. And that's it. That's all you really need to do. All right, but it's really understanding, in order for us to transform, to dilate, to either increase or decrease in size, but to keep the same shape, then that scale factor, we're just going to multiply it by each of the points that make up the shape. And that's it.